The bright yellow versus light yellow. Notice that the specific gravity changed very little. The pH changed somewhat. But the blood pressure of this person, went up a little bit, and you can see the other results that you got. The reason why we measure the respiratory rate, because I'm hoping that we can see the changes on the respiratory system, right? 20 minutes later, same thing. Person collected, then 20 minutes later, collection again, until they get to 120 minutes. All right, so this is one person that you're looking at here, from here out. Okay, here's another person. And that's the way the data is sorted somewhat. Right, so notice that the same thing is being collected. Volume, you're looking at color, you're looking at specific gravity. Notice that this person, for example, the specific gravity is much lower than that person. Okay, that the pH is a little bit different here than that person. So you need to watch those pH changes. Why am I looking at your pH changes? Because remember, a change in pH simply means a change in the hydrogen ion concentration. Right? So you need to look at that. And what you're looking for here is whether a particular solution can have a change in your pH because it's adding hydrogen ions to your plasma. So that's what you're looking for here. I want to show you a couple of interesting things in here. Go back in here and see if I see it. All right, I want to look at this person for a moment. This person drank sodium bicarbonate. It starts right here. 0.5 here. All right, so what I want you to do is look at the changes. Notice that the volume, very little P when the person started, right? That's normal. But notice what happens to the amount of that person drinking. Right? As time progressed, notice that the volume decreased from 83 to 0. I'm going to go back and I want you to look at the blood pressure. Drink here. Notice the blood pressure. Went from 131.81, 150, 178, and then it starts to go back down again. Right, so we've got to look for the solutions on whether a particular solution is going to make a particular change in your pH or your specific gravity. So here's what you need to do. Right, so you look at the solutions and try to get in your head a hypothesis of what each solution may cause in your body. Whether it's going to be a change on pH, whether you think you're going to see a change in a specific gravity or blood pressure or respiratory. So each solution has a slight different change on it. All I'm asking you to do is to look at the solutions. Don't look at just one. Look at all the people that have drank either whatever solution, and see if you see a pattern established here. And then all you need to do is write a paragraph about what do you think that you drink a particular solution changes to. First of all, to your cardiovascular system. Second, your renal system. And whether you see anything on your respiratory system. All right, so let me talk about this respiratory system issue for a bit. I posted this particular handout out there for you. And this is kind of a neat thing. I've done it only a couple of times, and I don't have enough data to tell you one way or the other. All right, so what I'm going to have you do is the following. This is very simple. I mean, this shouldn't take you, like I said, the biggest problem you're gonna have is staying, running in place for 5 minutes. Right, so you do the following. We're going to do a control. We're gonna take 2 flasks. Okay, one is gonna be our control, and one is gonna be the experimental. Okay? All right, you're gonna add 100 mLs, I think it says, of water, just tap water, to it. Right, we're going to run the control first because I need you to see that. But the procedure is the same. All right, you're going to add, say, 5 drops of phenolphthalein, and all the solutions are in the back. All right, so you're going to drop 5 drops of phenolphthalein. Right, then it says, where in the heck did I go? Now it says add 1 drop at a time of sodium hydroxide. Right, 1 drop at a time. If you read this carefully, it says 1 drop at a time. swirl it, and see if you see any change, right? Eventually, what's gonna happen is that the solution here is going to turn pink, and that tells you how much carbon dioxide is in it. All right? Once you determine that, it's just a matter of make sure that the pink color stays on for 15 seconds. I think that's what I wrote. Yeah. It says make sure that it stays pink for 15 seconds as you swirl it. If it turns pale, again, then add another drop until it remains pink for 15 seconds. That's all there. That's your control. Right, so here's the interesting part. To the experimental, those of you, those 5-6 people that are going to volunteer, I am sure, are going to do the following. You're going to run for 5 minutes. Right, after you run for 5 minutes, I'm gonna give you a straw. Okay, and you're gonna put the straw in here. And after the 5 minutes you run, you're going to blow air in it for about 5 seconds. I think that's what I wrote on it. Just make sure I think I wrote it, because I wrote this thing. Oh, sorry, it says 10 seconds. You're gonna blow in here for 10 seconds, and all you're doing here is adding CO2 to the solution, right? So then you're gonna add the 5 drops of phenolphthalein, same thing, and then you're gonna begin to add 1 drop of sodium hydroxide until the coloring here matches the coloring here, and that's when you're done. And that's all there's to it. Now, why am I having you do this? Because here's what I'm looking for. What I'm looking for, as I said to you, is whether drinking a particular solution can have a change in your respiratory system, right? Right. So say, for example, you look at this person and you say, I don't see any big changes in here. The respiratory system, the person's control was 3 drops of sodium hydroxide. It looked like there was a little bit of sodium hydroxide. I'm sorry. Yeah, this is sodium hydroxide being added here went from 3 to 6. That means that this person produced a little bit of CO2 in it, right? Because of the solution that person drank, can it have an effect, and can you add carbon dioxide to your system? So why am I doing this again? All right, remember this. Right. This is what I need you to remember. Right, so if you drink a particular solution, say bicarbonate will have the biggest change. Are you making it, are you producing more carbon dioxide? Are you going to see more carbon dioxide? And will that show up when you do the experiment? And that's what you're looking, that's the reason why you're doing this particular experiment, that running in place for 5 minutes. I just want you to see what the changes are between having no carbon dioxide or very little to when you have a lot. So that when you look at this data, then you'll know it. For example, look at this person. Started with 9 drops. I think this is the beginning of here. 9 drops, then the person went to 12, then it stays at 10. So very little change. Sometimes you see a drop. That means that you started with more carbon dioxide, and they do this. The person will be doing this. They blow on the experimental every 20 minutes, and that's what takes the longest for the experiment. And that's what I'm asking you to do. There's nothing else to it. I'm only doing an experiment in here. You, the student, happen to be the experiment. So I want to see whether drinking these solutions is making a change or a problem with your respiratory system. Because remember, I'm looking for changes in cardiovascular first, renal system second, and respiratory system first. All right? So are we clear on this? I want to make sure that you understand why we're doing what we're doing. Unfortunately, you don't get to drink the solution. That's the fun part, to see everybody running back and forth every 20 minutes with their teacups on them. And that's the fun part. You know, with everybody taping it out there. So I am sure that people that are watching you will have fun, but they don't get to do it for you this time, okay? So you're gonna have all the data, I'll post it out there, and all you have to do is write a paragraph. Remember, a paragraph is more than 10 lines, so don't be giving me 2 lines, those are not paragraphs. Okay, so if you look at the definition of paragraph, it'll tell you that at least 10 lines, single space, not 2 or 3, because I don't wanna see that, all right? Are we clear on what we're doing here? All right, so who are the volunteers? I need to run and get the straws from my office, but I need at least 6 people to volunteer.